Hello everybody, Namaste. Welcome back to my YouTube channel. My name is Anushka. I'm currently studying at Shri Venkateshwara College of Engineering. Today we'll be discussing about pipelining in microcontrollers. Pipelining, let's understand what is the technique of pipelining. Pipelining is a technique used in microcontrollers to improve performance by breaking down the execution of an instruction into multiple stages. Now, when you talk about an instruction has several steps to be executed. When you break down these instructions into multiple stages and perform it simultaneously, you get pipelining. Pipelining is nothing but execution of multiple instructions concurrently or simultaneously. These executions of instructions which are in a set are called instruction set, or perhaps instruction sets is nothing but a multiple instruction that needs to be executed. That's a instruction set, and in pipelining, an instruction set is executed. This allows the microcontroller to work on multiple instructions simultaneously, increasing the throughput, that is number of instructions per second, and reducing the time required to execute a program. Now, a program is nothing but a set of instructions. Each instructions have multiple steps. When these instructions are executed simultaneously together, this basically improves the overall performance and the program is executed faster. Let's understand the benefits of pipelining. There are three which we'll be discussing today: increased throughput, reduced latency, and improved utilization. Number one, increased throughput. Pipeline allows the microcontrollers to process multiple instructions concurrently, increasing the overall number of instructions executed per unit of time. As already explained, throughput is nothing but number of instructions per unit of time, as pipelining in microcontrollers allows the process of multiple instructions. This perhaps basically does what is the number of instructions per second is executed, or per unit of time. Let's not talk about seconds, but per unit of time is increases. As a result of which, the efficiency of a system is increased, and also the program executed is much faster. Reduce latency. By breaking down instructions executed into stages, the time required to complete a single instruction is reduced, as a result of which the instruction is executed faster, and thereby the program is executed even faster. Improved utilization. Pipelining helps to keep the various components of microcontroller, such as ALU, that is arithmetic logic unit, and memory, fully utilized. The utilization results in basically utilization improves the machine's capabilities and potentials, as a result of which the microcontroller performance increases. As these ALUs and memory, if you fully utilize, the system works efficiently. Let's understand the pipelining stages now. Number one is instruction fetch. Number two is instruction decode. Then you have operand fetch. Instruction fetch. The first stage of microcontroller where the instructions or they retrieve the next instruction from the memory. Instruction decode, the second stage where the microcontroller analyzes the instruction and determines the necessary actions. And then as the instructions contains a set of operands, we have operand fetch. That's third stage where the microcontroller retrieves the necessary data or operands for the instructions. Let's understand instruction fetch. Retrieves the next instructions. We have three stages in this. Retrieves the next instruction, loads the instruction into instruction register, and increments the program counter. All of these are very important steps. Let's understand it step by step. Retrieve the next instruction. The microcontroller retrieves the next instruction from the memory, typically from the program counter. As we know, the instructions are stored in the memory, and the instruction from the memory, and typically it's stored in the program counter. So we need to retrieve the next instruction from the memory, which is basically in the program counter. Then the instruction that has been fetched is to be loaded in the instruction register for further processing. Loads instruction into instruction register. Then you have increments program counter. After instruction is fetched, instruction that is to be fetched, the program counter is incremented to the next instruction in the program. And the first instruction is already being fetched. The program counter needs to point at the second instruction that needs to be fetched. Now that the instruction has been fetched, let's decode it. The second step is instruction decode. Analyzes instruction, determines instruction type, and prepares for execution. Number one is analyzes instruction. The microcontroller examines the instruction to determine the necessary operations and operand. Now that the instruction is is to be analyzed, we need to determine the operation that needs to be performed and the operands on which the operation needs to be performed. In an instruction, you basically have an opcode and an operand. Opcodes are basically telling you about the operation to be performed on the operands. Operands are on which the operation is to be performed. So if you need to add two registers, as we are talking about, as we'll be talking in terms of assembly level language, you use the instruction add R1, R2. The register that is kept prior, that is R1, is where the after the instruction is performed, the value is stored. And add determines the type of operation to be performed on the operands R1 and R2. Determines instruction type. Now, microcontroller, as it decodes the instruction, it also determines what type of instruction is to perform. We have various types of instruction: arithmetic like add, subtract, multiply; logical performs the bitwise operation; or memory access. Prepares for execution. As we have determined the type of instruction and analyzed the instruction, based on the instruction type, the microcontroller sets up the necessary components for the stage of execution. Next stage of execution. Now that we have understood what is to be done with the instruction, number one is fetch and decode. Now let's understand what exactly are we decoding. Operand fetch, register fetch, memory fetch, and immediate value. As we have determined and discussed that we have analyzed our operation, our instruction, then instructions contains a set of operands. Now we need to fetch for those operands for the operation to be. Number one is register fetch. The microcontroller retrieves the necessary data from the register file. As the name suggests, the data is stored in register and we just need to take it out from it. Memory fetch, it requires the microcontroller to fetch data from the memory location. And when we have immediate value to be fetched, the microcontroller may also use an immediate value specified in the instruction file. If you want to specify immediate value, you need to use the symbol hash followed by the value. Execution. Now we have our instruction fetched, we have our instruction decoded, and the operands are being fetched. Now let's understand what should be the execution to be performed. As we have already analyzed the type of instruction, we can have three types of execution. One is ALU. ALU is arithmetic logic unit operations. The microcontroller performs the necessary arithmetic or logical operations using the ALU. Memory access. If the instruction involves a memory access, the microcontroller handles the write or the read operation. Control transfer. For instructions that involve control transfer, such as jump or branches, microcontroller updates the program counter. We have write back. Stores result. As the instruction has been executed, you need to store your results. The microcontroller stores the result of the executed instruction, typically in the register or ultimately that is the memory location. Update the status flag. As the instruction has already been executed, the microcontroller updates any relevant status flag, such as zero, carry, or overflow. It can also be a negative flag. Prepare for next instruction. As the first instruction is to be has been executed, after the write back stage, the microcontroller needs to be ready for the fetch and execute the next instruction in the program. These steps that I have explained takes place in microseconds or perhaps depending on your microcontroller. As a result of which, these steps needs to be executed simultaneously in order to complete the execution of program faster. I hope you understood this topic. I'll see you in the next one. Keep learning. Thank you.